We are on another tutorial, and it's very good one, and it's on IUPAC nomenclature. And I will just go straight away, give the definition of IUPAC nomenclature, the meaning of oxidation numbers, and I'll talk about the rules. Talk about the rules governing the naming of compound, and then how to find oxidation state of some elements. So I'll go straight away and say what the meaning of IUPAC nomenclature. It's very simple. Talk about IUPAC nomenclature. We're talking about a system of naming chemical substances based on rules assigned by International Union of Pure and Applied Chemistry. As we've seen, the I here in the IUPAC stand for international, U stand for pure, union, P stand for pure, A stand for apply, and then C stand for chemistry. So when we name any chemical substance based on every rule assigned by this organization, then we call it IUPAC nomenclature. Okay, so we move on to what we call oxidation number or state of a compound or an element. And oxidation state of an atom is the charge the atom carries in its pure state. Simple like that. So the charge that the atom carries in its pure state is what we call the oxidation state. We talk about a lot of them, so you understand by the end of this tutorial, every student will be able to know all the rules governing the naming of, giving the calculating for the oxidation state of compounds and then for elements. So stay cool and then let's continue. So we have the rules. So the rules that we need to know if actually we want to name, find the oxidation state of a compound. The first one states that all elements in their free state have oxidation state of 0. Okay, so all elements in their free state have oxidation state or number of 0. So let's take for example, carbon is in its free state, so it's having oxidation number to be equal to 0. Okay, let's take something for nitrogen. It's in its free state, so the oxidation number for nitrogen is equal to 0. And then let's take something like magnesium. Magnesium, like this, is in its free state, so its oxidation state is equal to 0. So that's the first rule. The first rule states that all elements in their free state have oxidation state or number equal to 0. So let's move on to the second rule. The second rule is saying that the oxidation state of an element in its combined molecular or atomic form is 0. So whenever you are dealing with molecules or when you have elements which are combined in their atomic form, their oxidation state is also equal to 0. So if I have something like hydrogen molecule, it's having its oxidation state equal to 0, oxidation number to be equal to 0. When you have oxygen, it's having its oxidation state to be equal to 0. Hydrochloric acid, like this, its oxidation state is equal to 0 because it's in its molecular form. When you have something like chlorine, it's also having its oxidation number to be equal to 0 because it's in molecular form. So that's the second rule. It says that the oxidation state of an element in its combined molecular or atomic form is 0. Okay, so let's move on to the next rule and see how we can go. So after knowing all these rules, it will be very easy for you to name every to calculate for the oxidation state or number for any other compound or element given to you. Okay, so let's move on to the third rule. The third rule says that the oxidation state of an ion derived from a single atom is equal to the charge. Okay, this one is self-explanatory. The oxidation state of an ion derived from a single atom. So let's say a single atom. If you have something like ion 3+, I'm talking about the oxidation state of an ion. So ion 3+ is an ion. Okay, so because of the charge here, and we are saying that the oxidation state of an ion derived from a single atom is equal to the charge. So here we say that the oxidation state of this ion is equal to +3. Let's take zinc 2+. The oxidation state is equal to the charge carried by the ion. So the oxidation state is equal to +2. Let's take sodium, Na+, sodium ion. So the oxidation state is equal to +1. Okay, let's take oxygen. Oxygen 2-, the oxidation state is equal to -2. So that is the third rule. Let's move on to the fourth rule, and then let's see what we can also learn from this particular area. The fourth rule saying that the algebraic sum of all the oxidations of the elements in a complete ion or radical is equal to the charge on the ion. Okay, so let's take example so that I can use the example to explain this one. We have manganese, and this is also iron, so -1 here. So what we are saying that this ion or radical, when we talk about radical, talking about group of atoms that stay together as a charge unit. So you have manganese, you have oxygen here that stay together as a one unit. Okay, so when we are dealing with radicals and then we want to find the oxidation of this particular radical, we're saying that when we add the algebraic sum of this manganese and then the algebraic sum of this manganate and then the oxygen, when we add their oxidation state together, it should give us the charge carried by the radical. Okay, so here the whole of the algebraic sum of the oxidation state of manganese and oxygen is equal to -1. Let's take this one, SO4 2- like this. So the algebraic sum of the oxidation state of sulfur and oxygen here should be equal to -2. So that's the meaning of the rule 4, that the algebraic sum of the oxidation state of the element in the radical should be equal to the charge carried by the radical. Let's move on to rule 5. And then rule 5 is saying that the sum of the oxidation state of all elements in a neutral compound is 0. When we talk about neutral compound, sodium chloride is a neutral compound, so its oxidation state equal to 0. When you have H2SO4, okay, H2SO4 is also a type of a neutral compound, so its oxidation number is equal to 0. Let's take the last example. Water is also a neutral compound, so its oxidation state is equal to 0. Okay, so let's take the last rule and then we start naming some of the compound. The last rule is saying that that's the 6th rule. It says that the oxidation state of oxygen is in most substance is -2 except in peroxide where it is -1. Okay, so whenever we see oxygen in most substance, to calculate the oxidation state of oxygen is always -2. But when you see oxygen in peroxide, then the oxidation state of oxygen is not equal to 2 but it's equal to -1. So in peroxide, we have the oxidation state of oxygen to be equal to -1. So thank you for listening to this tutorial, and if you like it, subscribe to my channel. Also share this one to friends and relatives. Thank you.